Okay, let's continue. And we have Martin online. So, hi, Martin. Martin, do you hear us? Yeah, not yet.
Yeah, I hear you. Fine.
Oh, yeah, good. Yeah, welcome to RIGA COMM. And
Thank you so much.
Yeah, Martin will tell us about how to make happy workforce using AI. Right?
Great. Am I all set to go?
Yes.
If so,
You're good to go.
Perfect. Let me just try to share my screen real quick. Okay, I'm so sorry. There's some privacy issues. This will just take 1 second. Okay, I'm so sorry. I need to restart this Zoom app to be able to share my screen. I will be ready within a few minutes, so we're good to go at 14:10 as planned. I'm so sorry.
Okay, let's wait a little bit for Martin. Again. Okay, good to have you again.
There we go. You can hear me now, and you can also hopefully see my screen.
Yep.
Perfect. Thank you so much for having me at the RIGA COMM. I would very much like to be in Riga. Unfortunately, I wasn't able, but I hope this virtual session is fine as well. So yeah, welcome to my session about how you can optimize your workforce using artificial intelligence. My name is Martin Olstad. I work as an artificial intelligence developer in Visma Resolve. And for those of you who don't know Visma, at a glance, we're a software provider in Northern Europe, headquartered in Oslo, Norway, reaching almost 2 billion euros in revenue in 2020, close to 14,000 employees, and with more than 1.1 million customers in the private and public sector. But the topic for today is artificial intelligence. And before we get into the details and how this could relate to utilization of your workforce, I would just take the opportunity to talk a little bit about the progress in the field the past years. Because there's been a quite drastic change within the field of computer vision. As recently as 2017, you have this sort of fun issue where some quite high-end computer vision algorithms or APIs failed to distinguish between a blueberry muffin and a chihuahua. And today you have convolutional neural networks that's able to help radiologists in scanning X-rays. And another cool example within the field of autonomous motion is, of course, Boston Dynamics, where you had a dog robot who kept falling on banana waste. Always cracks me up. And then, of course, you have Atlas, which are now able to do quite elegant backflips, I would say. And then more recently, of course, you have within the field of natural language processing, GPT-3, where we already see quite a lot of cool applications. For instance, OpenAPI's Codex that aims to generate code by itself if you could provide just a brief description of what the code should do. And of course, you have DALL-E that could really help inspire some designers. You could just write, I want a picture of an armchair in the shape of an avocado. And then the GPT-3 system would understand the concept of an armchair, what the shape really means, and the concept of an avocado, and being able to put all of those 3 concepts into context and actually provide creative and imagined pictures of such an armchair. And from the examples here, you can see that is some of them I think is quite cool. So yeah, there's a lot of interesting applications within the field of artificial intelligence. But we're still not seeing too much of this in the workplace. And for instance, within the hospitals, there should be a lot of great potential. Also within schools, there's still a lot of manual planning going on. And in society in general, we hear a lot of talk about artificial intelligence, but I at least have yet to see too much of it in my daily life. And there could be a lot of possible reasons for this. One might suggest that the focus that the AI researchers, the problems they focus on, just aren't really exciting enough within the field of workforce management. So in the workplace, I would say that that's not really the case. There is a lot of research going on within applications of artificial intelligence for workforce applications, such as research in schedule or roster generation, in time series forecasting, and in route planning problems. Another reason could be that the technology just isn't mature enough. But yeah, I would say that's also not entirely correct. There are indeed some great performance demonstrated on the same research problems within AI labs and within academia. And another possible reason could be that customers and consumers just aren't really ready for the change or transition to a more artificial intelligence-based workplace. And even though the technology is available, people might just not be ready to use it. The best case scenario, I would say that's a bad excuse. Our experience from Visma is that users are indeed open, happy, and excited about using advanced and complex automation. There are indeed some, you could say, points you should address. There are some concerns people impacted by such automation might have. But I think if you could have a transparent system, you could really address those issues. And I think a lot of them are due to misconceptions that people impacted by such automation wouldn't get their sort of voice heard. I actually think that using advanced automation, you could, in a more objective way, make sure that every voice are indeed heard. I'm gonna get a little bit back to that later in the presentation. But if it's not the researchers' faults, it's not that the technology is not mature enough, and the customers and consumers could indeed be ready for such transition to a more artificial intelligence-based workplace. I think that the responsibility should be taken in a higher degree by the software providers. And we need to address sort of real challenges that lies behind the reason why we're not seeing this too much in the workplace. As for what those challenges are, I think it boils down to three sort of concepts. First of all, it's about data and what I've called conscious modeling. I think most of you have probably heard that machine learning, it would require a lot of data, both the quantity, you need sufficient quality. But it's also another aspect that I think is a bit overlooked quite often, and it's this modeling part. When all you have is a hammer, everything looks like a nail, so goes the saying. And I think the same goes quite often in the realm of artificial intelligence. There's a lot of problems that you could, of course, try to solve with the newest, most hyped model, but some things are best done with the classics. And yeah, I'll get a little bit back to that as well. But I think having a conscious aspect when you're trying to model a problem is always useful. But even if you have the data and you have the correct or appropriate model, there's also the aspect of computation and scalability. You need to be able to scale both in terms of the problem size, but also in terms of the number of customers you have. So that's also something we'll touch a little bit upon. And then at the end of the day, you want your model and your system to be used. So if it's not, if you're not able to create that trust between the end user through your product, then you won't really be able to make sure that whatever cool algorithm or model you have will be applied in real world setting. And if you can indeed solve all these challenges, I think you can create some great software magic in the workplace. I'll try to create sort of an example. Because at the end of the day, I really think that the best software are indeed the ones that we don't really use. Might be a little counterintuitive, but you could imagine that you're a hospital manager. You show up to work, and all your employees are automatically assigned shifts for the next few days or a few weeks. And the employees are indeed satisfied. They got their preferences heard, and they can be assured that it was an objective evaluation of all the different preferences. So they're satisfied, but also all their colleagues at the end of the day are satisfied. And as a hospital manager, you're also reliant upon having an inventory of medications available on short notice. But using an artificial intelligence replenishment procedure, you could automatically do that. It would just continuously run, and you could be certain that you always have ordered the right amount of medications readily available in your hospital. As for the nurses, some of them might be working in the home nursing care, meaning that they would visit elderly patients in their own homes. And those nurses would be assigned some familiar patients. So the patients could be assured that there's always a familiar face walking in the door. And the driving routes between the different patients would be optimized, such that the nurses can indeed spend as much as time possible with their patients, thus providing the best available quality in the nursing care. Then you have the birth department in your hospital, where newborn children are automatically assigned to the best fitting kindergarten in the area, accounting both for the capacity, of course, in the kindergartens, but also the preferences of the families who's having a child. And all of this is possible, I think, if we can meet the challenges outlined earlier. And to begin, you have the challenge of data and modeling. So as we already touched upon, and I think you're also familiar with this, is that you really need the right amount of data quantity and the right amount of data quality. It doesn't matter how much data you have. If there's a lot of missing values, if there's a lot of uncertainty in the data, if there's sort of different interpretations of the data, that should be consistent. But at the end of the day, you also need to really have a tailored solution. There is actually no one size fits all in this world. And I think, especially as newly graduates, you're really eager to test some new technology. You might want to use whatever you learned from university. But I think being a little bit conscious about what solution might actually fit best is important. And I wanted to bring up something that's not as heavily reliant upon a lot of data as other sort of machine learning models are. But that could still be a very useful tool when tackling planning problems. And this sort of modeling tool is quite often overlooked, I would say. It's called mathematical programming. And the key aspects of it is that you have a real planning problem. For instance, in a hospital, it could be a construction site. It could be pretty much whatever. But it's something you need to plan for, and you have a finite set of resources. So you would identify your real planning problem, and then you would need to translate that into a mathematical model. So you would identify all the decisions you need to make. For instance, what employees should work, what shifts. You need to identify what targets you have, what are the sort of goals for the planning. It might be that you want to maximize profits, might be that you want to utilize the workforce in the best possible way. There could be a lot of conflicting objectives as well. And then you need to identify your constraints. You might only have 10 people available in the department. You might only have one sort of constructing machine you could use at a time. And you need to identify those and translate those into variables, into coefficients, and into an objective in your mathematical model. And when you've done that, when you've translated the real problem into a mathematical one, in as good detail as possible, you would need to actually solve it. And you could do that using a search algorithm. Again, here, there's a lot of different algorithms you could use. And you do see a tendency of people trying whatever new cool thing they've heard of. It might work, but it might also not work. So I think you need to come to this step with quite an open mind. And genetic algorithm might work very well, but it might as well be that the large neighborhood search could be tailored to this problem to fit quite well. So you need to be conscious about your modeling, even in this step. And for mathematical programming, in contrast to more traditional machine learning, getting an answer out is quite computation heavy. It's comparable to maybe training a machine learning model. And thus, regardless of whether you choose a mathematical programming approach or a deep neural network, you do need a lot of computation. And that leads us to the next issue, which is just that, computation. You need to be able to scale both vertically and horizontally, both in terms of the problem size of the problems you're trying to solve, but also in the terms of number of customers. And I guess computer scientists often focus on the problem size part, while more business-minded people might focus on scaling with the number of customers, but you need to make both of them coming together if you're able to be able to solve these kinds of problems. So the first one is the problem size. And I'll share with you an example from my MIT professor from back in the days, who showed me this for why we need, you say, good search algorithms, why it's not just enough to try out every single decision, try out every single possible way to solve a problem. Because even though machines are a lot better than humans on computations, they do have their limitations. And with this mind experiment, we will come to that conclusion as well. So you could imagine that every single atom in the universe, and this is quite absurd, but every single atom in the universe is indeed a computer. And each and every one of those computers could calculate 1 billion chess moves per second. Given that, it would still take 1 billion years to find all valid chess moves, which is just an absurd amount of years. Billions times the number of years the current universe is. And it's just mind-blowing, I would say. If anyone have any questions regarding the calculations, I'd be happy to do that after the presentation. But it really gives a feeling that, okay, some problems are just not possible to solve to optimality. You can't really brute force your way to find every possible decision here. And this quite easily translates into, for instance, scheduling problems as well. Instead of chess bricks, you would have different employees, and each sort of chess brick type could be different competences, and then one specific configuration of the board could be one kind of schedule. So there's, and then of course the placing on the board would be what kind of shifts an employee is working. So the combinatorics explodes both in scheduling problems and in chess problems. And this sort of combinatorial explosion is really why AlphaZero is such an impressive feat. And it also quite clearly outlines why effective search strategies are so important. And I won't go too much into detail on this, but I think it's quite important to touch upon. And that is, what sort of design decisions do you then make when you're creating such search strategies? And I think at the basic level, it's what nodes to visit. So in a search problem, you would then have either a tree or a graph, like the one to the right here, where you are in one node, being the blue here at the top, and you need to move downwards or perhaps between different branches to find a specific node. And you don't know the value of that node yet, and that's what you want to explore. So you need to decide what nodes you want to visit. And there's a lot of different ways to do that. And you already know that you can't really visit every single node. You need to decide how many should you choose from. If you're in the blue node, and you would then immediately have 3 alternatives here. But in a real world problem, in real world setting, you wouldn't really have 3 nodes, you would have maybe 1 million. And you would need to sort of shorten the number of alternatives, maybe. You could also rely upon a specific policy, always choosing a node with a specific trait to make sure that you exploit the information you have to the highest degree. But you could also try to include some kind of stochasticity or randomness to make sure that you explore more of the tree. But then again, that might increase the time it takes to do the search. And whenever you have actually traversed the part of the nodes, you're not in the blue node here, but maybe you're down the tree here, and you want to look at a new node, you need to decide, should you look at just the local nodes, the ones below it, or should you be able to look at nodes in a completely different part of the tree? All of these are things you need to consider when you're designing and customizing your search strategies. And there's a lot of different possible choices, which is what I hope you take away from this slide. But even if you are able to have a great search strategy, you are able to solve real-sized problems, you also need to scale in the number of customers. And in Visma, our approach to this, or in Visma Resolve, our approach to this is to sort of compartmentalize the different algorithms or different optimization solvers as dependencies. And then we use state-of-the-art cloud technology, such as serverless and AVS, and the Visma developed Visma Cloud Delivery Model in order to make this available on demand. We get to spend the time on what we're good at, which is optimization and artificial intelligence, and spend less time on all the infrastructure and scaling of the different servers that is an outsourced to AVS. And then our solvers, our machine learning models, are available to our customers, which is other Visma companies, through an API, and they can create state-of-the-art artificial intelligence software to bring out to their customers again. So that's how we can ensure both scaling vertically and horizontally in terms of problem size and number of customers. But if you're able to do that, you have the data, you have the model, you have the scalability. At the end of the day, you really need to have a good user experience with your software in order to create the trust needed for the end users to actually applying it in a real world setting. And I think the key here is the intersection of knowledge sharing between domain experts, algorithm experts, and the last piece is user experience experts. So if you can make sure that all of those different kinds of people are able to communicate well and cooperate on creating such software, I think that's where you can create great automation software, especially within a workforce management setting. And I'll show you an example. It's automatic scheduling, where you need to, at the basic level, decide what employees should work what shifts in order to meet demand. And that problem description is quite easy to come up with, but there's a lot of nuances you don't really capture if you don't do indeed share the problem with a domain expert. Because you need to map the real problem, what the end users are actually struggling with. It could be that there's a lot of different restrictions when you need to schedule your employees. It could be that there's some demand you can't exceed. It could be that there's some rest you need to, continuous rest you need to adhere to. Or there could be some maximum working hour restrictions for the employees. But almost, or maybe as important, are the preferences. There might not only be a max demand, but maybe some ideal demand you want to capture. There might be that the employees might not want to work partial weekends. That is, if they work Saturday, they also want to work a Sunday. And of course, you want to take into account some desired or undesired times that the employees want or do not want to work. And then at the end of the day, you also want some sort of measurement of fairness, that it's not enough that just one employee is really, really happy about their schedule and everyone else is miserable. You want everyone to be quite happy, if not as happy as possible with their schedule. So you need some objective measurement of what's fair. And this is actually what we got when we mapped it out with mapped the scheduling problem out with some Swedish domain experts. But it's important to mention that these, of course, requirements may vary across different markets and countries. So when you're certain that you do indeed solve a real problem, you need to make sure that the complex planning problem you're trying to solve is actually wrapped up in an intuitive interface that the end users may easily interact with. You don't want the software to be as complex as the planning process itself. It should be an easy to use. So what we think is a good sort of recipe to make sure that you have an inclusive automation is to make sure that you do indeed solve the real problem, that you work with user experience experts to make sure that your interface in the final module is indeed intuitive to interact with, and ensure that you have a search strategy and a model good enough to efficiently and objectively provide the decision support needed. This way, you make sure that the user does indeed stay in control, and the decision maker at the end of the day gets to spend its time to focus on creating value rather than trying to solve some huge combinatoric puzzle. And I think the problem outlined in these presentations are indeed something we can solve. I think we have some evidence that it's at least partially solved already. In Visma Resolve, we do indeed offer some solutions using artificial intelligence to solve these kind of problems. You have automatic kindergarten admission, where we take into account both the capacity of the kindergartens as well as the family's wishes on where the kids should go to kindergarten. And we're able to make sure that even more families are happy with where the child goes to kindergarten. In the timetabling space, in the school space, we have a solution that assigns subjects, teachers to rooms, making sure that the entire year is mapped out within a few hours instead of having to spend weeks planning this. And of course, we have the automatic scheduling or rostering part, where we assist in planning high quality and fair shift schedules that adheres to not only regulatory requirements, but also takes into account the preferences of the different employees and ensures a fair schedule at the end of the day. Thus, within a few minutes, you could have a shift schedule for weeks ahead planned. And this is also something we have in the Swedish market already. And then we also have a route optimization product where you can optimize time spent with the patients, and also taking into account some quality measures, like there's always a familiar face walking in the door when there's a nurse visiting an elderly patient at home. And to wrap it up, in order to optimize your workforce using artificial intelligence, I think you need to have some software that's tackling these different challenges. The software needs to make some conscious modeling with sufficient data and sufficient data quality. You need to think scalability, both in terms of problem size and the number of customers. And you need to really identify the real problem with domain experts and present the solution in an intuitive way that's easy to use. We think we're able to do that, and that's why we're bringing automatic scheduling to Latvia through a company called Horizon, and we're really looking forward to that. That's everything I had. I hope it was interesting listening in, and if we have time for questions, I would be happy to answer those.
Yeah, thank you, Martin. And we have time for questions. So if you want to ask a question, please raise your hand, and I will come up with mic. Yeah, we have a question.
Hey, viens. Okay, you can hear me. Hi, Martin. Thank you very much for the presentation. It was good, valuable info. So my question is regarding the reasons why people are hesitant to implement AI. I didn't see one point which I think is a major point there in your presentation. I didn't see it, is the fear of AI. Like people who are in contact with AI and automatization know that the progress line in graph is not a steady line, it's actually progressive. The better the AI is, the faster it goes, and I think the fear for people of losing their well-being and losing their jobs is a real reason why AI is not being implemented in really fast ways in fields that it could be. And how do you see the future in, regarding this? And what needs to happen to kind of not, well, maybe to dull down this opposition to AI?
I think it's a great point you're bringing up, and I do think there are definitely some valid concerns with regards to this. If you've done something in some certain way for decades, and suddenly a machine should do it in a much shorter time, and the machine might not be very transparent either, it's definitely valid to have some concerns. I think what's important here is to meet sort of that opposition with an open mind, to hear out what concerns they actually have. And if you do that, I do really think that you could really resolve those concerns with existing technology. If you can really show that, for instance, their preferences, their wishes will be taken into account, that it's just not some machine randomly selecting, in the case for scheduling, for instance, randomly selecting what employees should work where, but it's something that takes into account what preferences the different employees have and really listens to them in a much higher degree than you are able to in a manual setting. I think it's that's the key, to really have the communication line open and trying to be transparent into what sort of you can say factors influence the decisions such an artificial intelligence system would make.
Yeah, okay, thank you. Any other questions? Okay, then, thanks very much, Martin, for presentation, and
Thanks.
have a nice day.
You too. Have a great time in Riga, everyone. Bye.
Yeah. And now we're going to break till 3:20, and we will continue with how AI transform retail, customer experience, how AI helps to build a better customer experience, and other topics. See you after break.